differential equation for our GATE examination. And again, differential equation is a very easy part to score in GATE examination. And again, I will recall here that if you are going through engineering mathematics in GATE exam, then your score will be increased by minimum 10,000 rank. Means here, if you are concentrating on engineering mathematics, if you are scoring near about 18 to 20 marks, then surely your score will be increased with a rank near about 10,000. Therefore, this is very important. Now, after vector calculus part, we'll turn to our next topic, that is a differential equation. And in this differential equation, we have to discuss solution of differential equation, and before that, formation of differential equation. After formation of differential equation, we will discuss about solution of differential equation. And here, I will recall all these parts of formation and solution of differential equation. First, we will discuss about formation of differential equation. If we are given family of curves which containing n arbitrary constant, our aim is to eliminate these n arbitrary constant by taking successive derivatives. By finding derivatives, we will eliminate these n arbitrary constant and will get corresponding nth order differential equation. Means main thing is that we have to eliminate constants from our given curve and we have to form a differential equation. Now, in this, what we are doing here? We are differentiating given curve to find our general solution, which depending on number of constant. Here, suppose containing n constant, then we have to differentiate this with respect to n times and eliminate these arbitrary n constant in terms of depending variables or derivatives. And from this we can obtain differential equation. Again, keep in mind the differential equation of family of curves of n parameters is a differential equation of nth order. It's containing n arbitrary constant, and surely we are getting differential equation of nth order. Now, how to eliminate this type of constant and how to form a differential equation is discussed by this example. Consider a family of parabola y is equal to 4x square. Here a is constant. If you are changing a, we will get here family of parabola. Our aim is to eliminate this a and we have to form a differential equation. Now, if we are differentiating this equation y is equal to 4x square with respect to x, then we will get here 8ax. And by using this equation, we will find a is equal to 4a equal, because 4a is that. So 4a is equal to 1 divided by 2x into dy by dx. Now I will replace this 4a term by this derivative and I will rewrite this out. Therefore, we will get here y is equal to x divided by 2 dy by dx. So we are replacing here this total term and then we will get here dy by x by 2 into dy by dx, which is equal to dy by dx is equal to 2y divided by x. This is our differential equation, and this equation is not containing this arbitrary constant a. Therefore, we are getting our differential equation. And moreover, only one constant is there. Therefore, this is first order differential equation. Now, again, we will discuss our next example. Y is equal to a into e raised to x plus b into e raised to 3x. Now, this family of curve containing two arbitrary constant a and b. Therefore, surely whatever it is, the answer we are getting is the second order differential equation. And our aim is to eliminate these arbitrary constant by taking derivatives. I will take here first derivative y1 is equal to a into e raised to x plus 3 b into e raised to 3x. Second arbitrary constant means now we have three equations. This first one, y is equal to a into e raised to x plus b into e raised to 3x. In this equation, y1 is equal to a into e raised to x plus 3 into b raised to 3x, y2 equal to a into e raised to x plus 9b into e raised to 3x. eliminating this constant a b by taking determinant, and here we'll write component. Here I will write here from left hand side. Here this is component of a into e raised to x is common. Here b into e raised to x is common for every equation. Therefore, component of this a into e raised to x, coefficient of this is 1. Therefore, here I am taking 1. Coefficient of x is 1. Here is 1. And this y, if we are taking to right hand side, we will get here minus 1. Similar way here for this equation, we are getting 1. This is 3 and this is minus y1. For this is 1. Here is 9 and here minus y2. If we are solving this determinant, we will get here y2 minus 4y1 minus 3y equal to 0. That means this is our second order differential equation, d2y by dx2 minus 4dy by dx minus 3y equal to 0. And in this way we can eliminate these arbitrary constant here a and b, and we get here new form. This is called global form of this family of a curve, that is a differential equation. Now after this we will discuss next part, that is the solution of differential equation. And here this is very important part, because most of the time in GATE exam they are asking problems on solution of differential equation. Now there are several methods are there to solve a differential equation. I will recall all these methods, and based on that some examples we will discuss, and at the end we will discuss some examples from our last GATE exam. Variable separable form. Again, name itself giving variable separable means whatever variables are there, we have to separate these variables. Suppose we have differential equation m into dx plus n into dy equal to 0, and suppose is containing xx term, we have to collect one side, yy terms we have to collect another side, and then this becomes easy to integration, and this method is called variable separable form. Means here in this m and n we can easily separate these variables in terms of xx variable and yy variables. Here we have this equation in variable separable form. And next, this is function of x, and y, this is function of y. We can separate this, and if we are integrating this, we get our solution. Now here one example is there. Again, this example is from your last GATE exam. Here dy by dx is equal to minus 5y. Initial condition is y is equal to 2 at t is equal to 0. The value of y at t is equal to 3 is options are given. Now dy by dt, and this is 5y, therefore easily I will take this 5y to this side. That means this is under variable separable form. Here we can write dy divided by y, which is equal to 5t. If we are integrating this, integration of this is log y is equal to minus 5t plus this integrating constant. Now this initial condition helps to find out this constant. Now I will use here y is equal to 2 at t is equal to 0. If we are putting t equal to 0, this total sum becomes 0, and we are getting y is equal to 2. Means here this is equal to log 2 equal to minus 5. Log 2 equal to minus, log 2 is equal to c. Okay, before that we'll write this equation in this way. Y is equal to e raised to power minus 5t plus c. E raised to power minus 5t plus c, and we can express this as e raised to power minus 5t into e raised to power c. Now this e raised to power c is again constant. I will write here this is a. Means here we are getting solution y is equal to a into e raised to power minus 5t. Using this initial condition y is equal to 2 at t is equal to 0, we will get this value of a is equal to 2. Again here also if we are putting directly, then also we are getting this answer. Here we are getting a is equal to 2, and solution is y is equal to 2 into e raised to power minus 5t. But this is not answer. We have to find out this value of y at t is equal to 3. Therefore we have to put t is equal to 3 here. Then we will get y is equal to 2 into e raised to power minus 5 into t. 5 into 3, 5 3 the 50. And we are getting this y is equal to 2 into e raised to power minus 15. This is our correct answer. That means 2 into e raised to power minus 15 is our correct answer. That means option C is that. Here this is next example, most of the time this example they will ask in our exam, dy by dx is equal to under root of 1 minus y square divided by what under root of 1 minus x square is equal to 0. Again, this is very easy to convert it to variable subtotal form. And here, if we are separating this y terms and xx terms, dy divided by under root of 1 minus y square is equal to minus dx divided by 1 minus x square. Integration of this total term is sin inverse of y is equal to minus sin inverse of x equal to 0. This is our solution of your equation. This is under variable subtotal form. In variable subtotal form, we can separate variable xx variable and yy variable, and then we can integrate this. Now next method is homogeneous differential equation. Homogeneous equation means our terms are having same degree. Then this equation is called homogeneous equation. And if this homogeneous equation containing derivative, so this is called homogeneous differential equation. Remember this, homogeneous term means all degree of each and every term in that equation are same, and again this equation containing derivative, then this is homogeneous differential equation. So to solve this homogeneous differential equation, I will consider this is homogeneous differential. Moreover, m and n both are in homogeneous form. And to solve this type of differential equation, every time we have to put y is equal to x, put y equal to vx, then differentiating this dy by dx is equal to v plus x into dv by dx. This conversion factor, if we are converting in our given equation directly converted into variable subtotal form, and then we can solve this by creating it as a variable subtotal form. Now we will consider this example: x plus y into dx plus y minus x into dy. Now this equation here, if we observe coefficient of dx, this is x and y, degree of this term is 1, this term is 1, therefore this homogeneous of 1, this term is again 1, here this degree is 1, this is again total coefficient of dy is again homogeneous, therefore coefficient of dx and dy are homogeneous, and you can write here dy by dx is equal to minus x plus y divided by y minus x. Now this is homogeneous differential equation. Here numerator is homogeneous form, denominator is homogeneous form of degree 1. Therefore we have to put y is equal to dx and dy by dx is equal to v plus x into dv by dx, which is equal to minus x plus dx minus x. Then x will get cancelled from numerator and denominator, we will get this. Now from this term and this term will take v to right hand side, and if we simplify this, then directly we will get x into dv by dx is equal to 1 plus v square divided by 1 minus v square. This is in variable subtotal form. Now we will take v term separately and xx term separately, and we will get here 1 minus v divided by 1 plus v square is equal to dx divided by x. We have to integrate this. We will integrate this by taking separate term 1 divided by 1 plus v square and minus v divided by 1 plus v square. We can write it this way. This is equal to integration of dx into x. This is integration, which is equal to this integration is directly we are getting tan inverse of v, and here we have to make adjustment because denominator is here 1 plus v square, derivative of this denominator is 2v, therefore I am taking multiplying 2 and dividing by 2. This total term derivative of denominator is in numerator, therefore this is log of here 1 by 2 into log of 1 plus v square, which is equal to this log x plus c. This is nothing but tan inverse of, we have to put v is nothing but v is our y is equal to vx, therefore y is equal to vx, therefore v is equal to y divided by x. If we are replacing v by y divided by x, then we get our solution. This is our solution under homogeneous. Only remember here, if our problem is under homogeneous form, only we have to replace and we have to convert this in variable subtotal form by putting y is equal to x. Now exact differential equation. This is somewhat important because if equation is in exact form, then it is very easy to solve. When our differential equation is said to be exact, our differential equation m into dx plus n into dy equal to 0. This differential equation is exact if double m by double y is equal to double m by double x. There is a mistake here. To write x double m by double y is equal to double n by double x. This should be x, and its solution is integration m into dx. We have to take this m as it is, keeping y as constant. Integration terms of n is terms of n not containing x. Which we have to take such a terms of n which are not containing x. This is equal to c. This is our exact differential equation and its solution. Solution we can write here directly m. We have to integrate this with respect to x, creating y as constant, and we have to select such a terms of n which are free from x, which is equal to constant c. Keep in mind here should be double n by double x. Now example based on this, solve exact differential equation. Now here this word is very important. Solve exact differential equation. There is no need to check this condition. Directly given. This is exact. Therefore, what is solution of exact differential equation? M into dx, keeping y as constant, plus integration terms of n which are not containing x into dy equal to constant c. Now here this is total term is our m. We are taking total term plus we have to take such a terms from this n which are free from x. Now this first term containing x is sin x, and here cos of x plus y, this total term containing x. Therefore here this becomes 0, and integration of this term with respect to x, integration of cos term is sin x into tan y is constant, plus integration of cos x plus y is sin x plus y, which is equal to constant. Here if equation is in exact form, easily you can solve this. Now partial here in a linear differential equation. This linear differential equation here, most of the time they are going to ask problem on this linear differential equation. Linear differential equation of first order and first degree is the dy by dx plus py equal to q, where is p and q, these are the functions of x, or sometimes they may be constants. And to solve this differential equation, important thing is that we have to calculate first integrating factor. And integrating factor is e raised to power integration p into dx. What is p? P is coefficient of y. P into dx. This is our integrating factor. If we are finding integrating factor, we get our solution. Y into integrating factor is equal to integration, this q. Q means right hand side. Q into integrating factor into dx plus c. This is our solution. Means y into integrating factor is equal to integration q into integrating factor into dx plus c. Again, see here, this q becomes 0, that means this becomes homogeneous form. Then this total part becomes 0, and we get our differential equation solution as y into integrating factor plus c. So write in this form dy by dx plus py equal to q. We are getting p is equal to cot x and q equal to cos x. Then we can find here integrating factor. Integrating factor is e raised to power integration p into dx. P is here cot x. Cot x means cos x divided by sin x, and derivative of sin x is in numerator, that is cos x. Therefore directly you can write this integration as log of sin x. E raised to power log sin x is net sin x, and we are getting this integrating. If you know integrating factor, the solution is y into integrating factor is equal to integration this q right hand side term into integrating factor into c, and solution is y into integrating factor. So y into sin x is equal to integration sin x in cos x into sin x integration. Now here we can use the directly formula, because sin 2 theta we are knowing. Sin 2 theta is equal to 2 sin theta into d theta. Sin 2x is equal to 2 sin x into cos x. And here we can write this formula, and therefore we are getting this equation. Y into sin x is equal to, I will make adjustment here 1 by 2 and write in here sin 2x. And this is equal to y into sin x, here should be 1. Y into sin x is equal to 1 by 4 into cos of it plus c into our solution. Here is y into sin x, here is y into sin x plus y into. Okay, thank you.